So today we're going to finish up chapter 1. So you should have your packet for 1.2. In section 1.2, we're going to discuss the types of data. So if you will locate that, please. So information is collected on individuals. The characteristics of the individuals about which we collect information are called the variables. The value of the variables that we obtain are the data. The information collected is the data set. So first off, we're going to talk about two types of data. Now, the two types of data that we deal with are going to be qualitative and quantitative. You can see right here that you have qualitative and quantitative. Now, qualitative variables are referred to as categorical. It deals with categories. For example, when you're thinking about categories, you can think about color, gender, those kinds of things. Nothing you're really going to do math with, but when you get to quantitative deals more with numerical and math. So qualitative is going to be categories that are usually non-numerical. Quantitative will deal with numerical, but the numerical part means that math operations make sense to perform with them. So when you think about quantitative, you're measuring how much or how many something there is. So it's going to deal with measurements. So if you were to deal with a number such as a jersey number, you're not going to add jersey numbers together and do math with them. That makes absolutely no sense. So that would be a category. It would be more qualitative. It's going to describe who you are, like a quality, what number you are on a sports team. So one thing I wrote out that I really feel like you might want to add to your notes, with this is there are two types of data. When you're dealing with qualities, you're dealing with words and labels. Quantities are dealing with counts and measurements. In qualitative data, math operations are meaningless. In quantitative data, math operations matter. So we're going to look at some examples in the packet for section 1-2 and see what you would think. So a person's age. So when you think about a person's age, can we do math with a person's age? Of course, we have birthdays. We can add years to that. We can add years as we're getting older. So we can actually do math and that makes sense. So a person's age would be a quantitative variable. A person's place of birth. We're not really going to do math when it determines a person's place of birth. Being born in one area is not going to be given a number, and then you're going to add or subtract a number from being born in another area. This is a quality. This is something that categorizes who you are by where you were born. So this would be a qualitative variable. Letter C, the mileage of a car. Of course, you can do math with the mileage of a car because you can have miles per gallon and you can see how many gallons of gas your car will hold. So math dealing with the miles in a car, it also accrues as you drive your car more. So you acquire more miles on that car. So math does make sense, which makes that a quantitative variable. And the last one is the color of the car. Even though we have preferences on what color of the car we prefer, you're not giving a certain color a number. Just because I might like red and you like white doesn't mean that mine is better. It's just a quality that I have, that I prefer to have a certain color of a car. So again, we're not doing math on that. That would be considered a qualitative variable. So I would make this chart on a separate sheet of paper for help. So when you deal with qualities where the math is meaningless, that deals with two types of data, such as nominal and ordinal. Nominal deals with names. Names can be determined by color, gender, social security number, jersey number. That names who you are. That tells a person your qualities. Now, once you can go from nominal to ordinal, ordinal means that you can order that data, which means it is also a qualitative variable. So when you look at a movie rating such as G, PG, PG-13, and R, that can be ordered in a specific order. However, you don't really know the difference mathematically between one movie and the other. Just like you can order small, medium, large, extra large, extra, extra large, you can put these in order, but you don't really know the differences between each size numerically. The same with first, second, and third. The distances, if somebody come in first versus second, might not be the same distance as that person who come in third. So we just know that that's the way they're ordered, and that is their rating. So when you think about those two, they're going to be categorical. Ordinal is going to deal with order, and nominal is going to deal with names. So as we try the examples, a state of residence. So basically, we're not ordering the states and saying one is better than the other. So that would just be naming. So that would be nominal. The next one would be gender. You can't say that one gender is better than the other. You're not going to order those in a specific order. So gender would also be nominal. The letter grade in a class. Those can be ordered A, B, C, D, or F. So ordinal is order. The size of a soft drink. Those can also be ordered when you deal with soft drink sizes. So that would be ordinal. Small, medium, large. So nominal, again, deals with names, labels, categories, male, female, jersey numbers. Ordinal deals with order. So you ask yourself, can you order or rank it? If you can, it would be considered ordinal. The next two words deal with discrete and continuous. Discrete means that you can count. So discrete is countable. Continuous is typically something that is measured. So you need to remember discrete, countable, continuous, measured. So always ask yourself, can you count it? If you can, it is discrete. If you can measure it, it is continuous. So when you're counting something, we could count the number of students in a classroom. Those can be listed 1, 2, 3, 4, so forth. That would be considered discrete. If it is continuous, we are measuring. They can take on any value within an interval. So when you're dealing with height, weight, those things that are measured would be something within an interval. They would be connected and have infinite number of possibilities. So when you're dealing with that, remember discrete, countable, it is finite. You only have so many choices. Continuous is infinite, and you have many, many different choices. So as we look at the examples, we're deciding if it's discrete or continuous. The age of a person. The age can be counted. You tell the number of years. Therefore, it is discrete. Number 2, the height of a person. Height is a measurement. Therefore, it is continuous. It uses intervals. 4 feet, 4 feet 1, 4 feet 1.5, 4 foot 2. It uses all kinds of intervals. Continuous. Remember, ask yourself, do you count or measure? Number of siblings. Would that be a count or a measurement? That would be a count. Therefore, it would be discrete. And the last one, the distance a person commutes to work. That would be a measurement. So you can measure how many miles a person might go. So that would be continuous. So with the quantitative that can be counted or measured, it is broken down to interval or ratio. Interval deals with things like years, temperature, equal differences on a scale. So when you're thinking about that, 0 is just a position. These numbers would not be negative. These numbers can be negative. So when you think about numbers that can be negative, like with our temperatures that go below freezing. So these numbers are able to have negative values. 0 is a position. Just because it's 0 degrees doesn't mean that there's not a temperature. Ratio is weight, age, height, salary. 0 does mean the absence of value. You can make 0 salary. You can have 0 weight. So 0 is absence. And this is the most precise measurement. So as you look at objective 5, distinguishing between ratio and interval, ratio deals with zeros that represent the absence of a quantity. 0 actually means none. Also with ratios, you can think of that as fractions. Someone can have twice as much as someone else. Someone could have a fourth as much. So a ratio, you could ask, can they have as much, twice as much? In interval, you would not have that. Interval is where 0 doesn't represent the absence of a quantity. Also, you can have negatives with intervals. And temperature is definitely going to be interval. So make sure you remember that one because that one will probably be asked. And also think about plotting it on a number line. Okay, the number of siblings a person has. So that is definitely countable. So we can actually say that it's quantitative. So now we need to determine if it's interval or ratio. So ask yourself the question, can you have 0 siblings? If you say yes, then it is going to be ratio because 0 means none. So you can have the absence of siblings. Also, it makes sense to say that someone could have twice as many siblings as another person. The outdoor temperature in degrees Celsius. That is quantitative. You can do math with temperature by seeing how much warmer or cooler it is each day. So this with temperature can be negative. You also can think about temperature as being a position on the scale. So temperature is interval. 0 does not mean no temperature. It doesn't make sense to say it is twice as warm. The year, the next presidential election. So when you think of years, that definitely math makes sense. Every 4 years. So when you think about that, does 0 mean the absence of a value? So when I think about that interval, 0 does not mean the absence of time. Interval is a position on a scale with a timeline when you think of that in history. So that would be interval. The price of a pair of shoes. Can 0 mean nothing, which means you have absence of a value? So when you think of your shoes, yes. So it would be ratio. Also, it could mean the absence of a price. And some shoes cost twice as much as other shoes. So that also tells us that it would be ratio. So we have now finished section 1.3. As we finish chapter 1, 1.4 deals with bias. So with bias, when something is biased, that means that it is not being representative from which it is drawn. You want to make sure things are not biased. You want it to represent the population. You want it to, you don't want it to underestimate or overestimate a population. Because if you do that, you are showing bias. You want the study to be unbiased. You want things to be equally chosen. You want it to be representative of the population where you will get a good statistical study. Make sure everything has an equal opportunity of being chosen using random sample. So you will get a good representation of the population.